In the last couple of videos, we looked at stored procedures, how to call them, and also how in some cases we can get data back. As already discussed, stored procedures are designed to execute a sequence of SQL statements and can perform multiple operations within a single call. They can modify the state of the database, meaning they can create, update, or delete data as the AddAlbum series of procedures did. Procedures can also control transaction management, ensuring data consistency and integrity. In relational database management systems like MySQL, precompiled collections of SQL statements can be either a stored procedure or a stored function. Both are stored in the database, and both can be executed as a single unit. While each may encapsulate common database operations, they are different. Specifically, stored functions are designed to perform a specific calculation or data manipulation and return a single value. The key characteristics of a stored function are 1. As I just stated, it returns a value. Stored functions are expected to return a single value, such as an integer, string, date, or a result set. 2. A stored function is immutable. Stored functions are generally designed to be deterministic and should not have side effects. This means that calling a function with the same inputs should always produce the same output, and functions should not modify data in the database. Lastly, a stored function can be used in SQL expressions. This means you can use it directly in select statements, where clauses, or join conditions to compute values used in queries. The table on this slide lists some of the use cases for each of these stored objects. You can think of a function as a targeted and individual unit of work. It can be used for validating data before insertion or updating. A stored function can be used for converting data from one format to another. It can be used to reuse complex expressions that are used frequently. Finally, a stored function is often used to perform some calculation or formula. On the other hand, the stored procedure is like a mini program in the database and has much broader objectives. Use a stored procedure for data modifications like inserting, updating, or deleting records. Stored procedures are often used to extract, transform, and load data, making use of functions to load data from one table to another. Or maybe you've got some business logic. These rules can be encapsulated in a stored procedure. And we've already seen that a stored procedure can be used for batch and transactional processing. You might be less likely to call a stored function from your callable statement than you would a stored procedure, but I still want to cover it. There are a couple of differences. The first is that the SQL string will always start with a placeholder, so a question mark for the returned result. The second is that MySQL stored functions only support in parameters. This isn't true for other vendors. This just means you don't specify parameter types in the parameter declarations of the stored function in MySQL. First, let's get started by loading and examining a simple function in MySQL Workbench. First, download the file called calcalbumlength.sql from the resources folder of this video. Open MySQL Workbench and use the development session we've been using all along. Make sure you have the Schemas panel open. Select the second icon from the menu of icons, which is Open an SQL script from a file. Browse to the file you downloaded and select that. I'll select the first lightning icon and that will execute this script. If I refresh the Schema panel, I can open the Functions node. And there, I can see the new stored function there, calcalbumlength. I'll select the tool icon. What you'll notice is that this looks a lot like a stored procedure. It has the keyword function instead of procedure, but it has parameters defined in a similar fashion. One thing I want to show you is, if I now decide to declare the input type explicitly by adding the keyword in before album name, notice that this is an error in this case. This is one difference, that you don't have the option to specify the parameter type in your stored function because all parameters are by default type in parameters. I'll revert that change, removing in from the parameter declaration. The next thing you'll notice is that this function returns a double. and then notice the next line that says reads SQL data. I'm going to remove this for a minute. I'll apply this change and hit apply a second time. Now, I've got a problem. There was an error while applying the SQL script to the database. I'll scroll down a bit until I see error 1418. Here, the statement says this function has none of deterministic, no SQL, or reads SQL data in its declaration. You might remember in my introductory slides, I mentioned that function should be immutable or deterministic. Deterministic means that running the code with the same input should result in the same output each time. And they should never have side effects like altering the database state. I should specify at least one of these statements in my function, or if none of these is the case, I can pursue another option which I won't get into in this course. I'll cancel out of this, and now in my code, I'll type deterministic where I originally had reads SQL data. And I'll try to apply that. This time it works, meaning it got saved and compiled without any errors. Although this may work, it doesn't really make sense in this case unless the data in the tables will never change. If the data can change, then it won't be deterministic. So I'll revert this code back to the way it was. This is a really simple function. First counts the number of records in the album view for a single album. Then the code multiplies this by the static value 2.5. If song length were part of our songs table, then we'd sum up those values. So here, I'm just mocking up an average length of 2.5 minutes per song. That is selected into the length variable, which gets returned from this function. What's kind of nice about functions is that we can use them in select statements and where clauses. I'll show you this in the workbench, so I'll open an SQL tab. I'll select the distinct album name just in case this data has duplicates, and now, instead of adding another column name, I can call my function, passing it the album name column name. This means this function will get called for every record with that record's album name to calculate the album length. I'll select from the albums table and order by album name. I'll execute this, and you'll see a grid displayed, first my album names listed alphabetically, and then the result of my function, a double value representing the length in minutes of each album. This gives you an idea of relative length if all the songs were a uniform recording size. Now, let's see how we'd use this in Java code. I'll go back to my prepared statement project in IntelliJ. I'll be adding code to call this function in the music callable statement class. First, I'll comment out the code that calls the stored procedure. I use a block comment here, blocking out everything from the callable statement declaration down to the end of the for each looping. I'm going to call my function after the data is printed out, so after main.printRecords. Whether you're calling a stored procedure or a stored function, you still call prepareCall on the connection. This time I'll assign it to a callable statement variable named CSF. I'll pass the string that calls the calcAlbumLength function. In this case, start with a question mark and equal sign, followed by the keyword call, then the stored function, music.calcAlbumLength, and that takes one parameter. The first question mark is for the result of the function. I only need to register the result once, and this is done just like an output parameter. The returned result is index 1. I'll use the java.sql.types class to specify the type as a double. Next, I'll loop through my data in the map, so through the key, the artist, and the nested map, which is all the new album data. I'll loop through album map, but just the album name keys. I'll include a try clause. I'll set the function's parameter, index 2, to the album name. What this means is, I'll be calling the calcAlbumLength for each of the Bob Dylan albums in my map. Next, I'll call execute on the CSF statement. I can get the result from the statement by simply calling one of the get methods on index 1. I'll print this data out, so length of %s, that'll be the album name, is %.1f, that'll be the record length. and next, the usual catch clause. Okay, so this code is similar to calling a stored procedure. I'll run this now. But for this, I'm getting an error. Parameter number 1 is not an out parameter. This error is a bit confusing if you don't understand the problem. I'm going to go up to the prepare call method and make a minor change. I'll start and end the text that's in quotes with an opening and closing curly brace. I'll run the code again and scroll to the bottom of the output. Here, you can see the code ended without any errors, and I get the album lengths back from executing my function this way. The length of Bob Dylan is 32.5 and the length of Blonde on Blonde is 35.0. What are the curly braces here, and why did this work? Without the curly braces, the JDBC driver interprets the string literally, so it wants to execute a call command on the database. But in most databases, you don't execute stored functions using the call keyword like you would for a stored procedure. Because it thinks you're calling a stored procedure, the starting question mark is simply ignored. That's why we got the error in the first try. The parameter number 1 is not an out parameter because the driver didn't factor in the first question mark. Using the curly braces informs the JDBC driver that you want it to perform extra processing or translation. These curly braces are called an escape sequence and they are supported in special cases. JDBC escape sequences provide a way to execute database-specific operations in a more consistent and portable manner across different database systems. They're enclosed in curly braces and are used within SQL statements. There are certain things that aren't database agnostic. This includes date, time, and timestamp literals. You saw this when I gave you a specific format for the date in MySQL in a challenge. The default date format is different depending on the database. Scalar functions such as numeric, string, and data type conversion functions may differ. For example, the function to transform a string to uppercase may have a different name in various databases. Escape characters for wildcards used in like clauses may be different between databases. And the execution of stored procedures and functions may be performed with either a call or execute method or some other keyword. Similarly, the execution of a function may be performed differently across databases. For these features, and a few others, you can use an escape sequence, usually with special syntax specified. In the case of stored functions, the key is the question mark equals call part of the string. This informs the JDBC driver that you want it to prepare the code to execute a function. The other items listed on this slide have special indicators as well, and you can find these by googling JDBC escape sequences if you're interested. You might be wondering why I didn't need the escape sequence for the stored procedures we looked at in the last video. In general, the keyword call is supported by most databases for stored procedures. This means I could go over to the MySQL workbench and execute the call command with the procedure name and specified parameters in an SQL query editor. I could do the same in most RDBMSs, so the use of the escape sequences in a stored procedure call is often optional. The execute of a function isn't done with the command call in MySQL, so as you saw, we needed to escape this string, which allowed it to run successfully. Stored procedures are designed for executing multiple operations, modifying data, and enforcing business logic. In contrast, stored functions are primarily used for calculations and data transformations. Both enhance code reusability, improve performance, and promote encapsulation of complex database operations. And even better, they simplify the JDBC code you have to write. Now that you're a little familiar with stored procedures and stored functions, I've got a challenge for you coming up next. So I'll see you in the next video for that challenge.